All right, so working answers for these guys. So remember, these are equivalent ways to write the same degree measure. So when we see like that 67.526, that's the same as saying 67 minutes, 67 degrees, 31 minutes, 34 seconds. So that 31 minutes and 34 seconds tells us it's a fractional part of a degree. So whenever you see those, it's just a little bit bigger than the degree measure you see first. So 67 point something, somewhere between 67 and 68. You just want to remember minutes are 60ths and seconds are 3600ths. Just like if we think of our degrees like an hour, it'll make those conversions easy. For that bottom one, you don't round until the very end. So that 31 is just the number in front of the decimal. That's our minutes. And then at the very end, I get a 33.6. We just round to the nearest second. So that's where we get that 34 from. The top one, you don't have to round at all. Okay, yeah? That is the decimal that's left over from this first calculation. So same thing here, like we had a 0.5, so we use that multiplied by 60 again. So it's a fractional part of a minute that we want to convert to a smaller unit. Okay. Other questions on these? DMS, degree minute second, to decimal degree, and vice versa. Okay, next slide's a quick one. It talks about a review term from geometry, so complements and supplements. Complementary angles add to 90. Supplementary angles add to 180. One thing you maybe didn't talk a ton about when you did these in geometry is that in both cases, the two angles that add together must be positive. You cannot have a negative angle. So we want to keep that in mind for these problems. So 67 degrees, can you tell me what its complementary angle is, what its complement is? What do I need to add to that to get to 90? These are quick little do it in your head problems. What do we get? 23 is its complement, correct. Its supplement is the angle we need to add to it or work backwards, get backwards from 180. 180 minus the first will give me the second if you want to do it that way. What's my supplement? To get to 67 and total of 180. 113 is correct. Okay. Then we look at 110. Is there a positive angle we can add to 110 to get 90? There's not. So we say that the complement does not exist. There is none because it would have to be a negative angle. But it does have a supplement. Supplement is, what do I need to add to it to get 180? 70. If you have an angle bigger than 180, like let's say I had 200, it doesn't have a complement or a supplement. Quick little definition. Any questions there? Okay. Great. All right. How many of you remember radians from Algebra 2? Does the word sound familiar? Like you probably learned it before? Okay, guess what? We use radians more than degrees in this class. It's a really, really big idea. So if you don't remember it, we're going to do a quick little refresher. So what is a radian? So a radian on a circle, an angle that I can form as a central angle. If I take my radius and I stretch it around the circumference of the circle, I can get 2 pi of those to fit around my circle. So you can see that picture here. Here's my R, and then I can stretch it 1, 2, 3, 4, 5, 6, and a little bit. And actually, this little bit is another 0.28. So 6.28 radii. If I divide that by 2, I get 3.14. I get pi. So half of a circle is pi radians, pi R values around my circle. And then a full circle is 2 pi radians. We use those relationships to do our conversions. And we'll figure out exactly how many degrees 1 radian is in a little bit. So if I think about half of a circle is about 3.14 times I can go around the circle. That's where this conversion on the bottom comes from. We know that half a rotation is 180 degrees. We also know, if we're talking about radians, it's pi, about 3.14. So these are equivalent. If I want to convert from degrees to radians or radians to degrees, when I multiply this, it's just like multiplying by 1. It's two equivalent ways to say the exact same thing, something divided by itself. They're just measured in different units. Like if I say 12 inches and 1 foot, means the same thing. So that's what we want to think of radians as. Just another way to measure an angle, but it's in terms of pi, okay? So these at the bottom, you want to circle those. You're going to use them a lot. If you want to convert from degrees to radians, you're going to multiply by pi over 180. If you're going to multiply or convert from radians to degrees, you're going to multiply by 180 over pi. You're just going to flip it. So multiplying by 1 in either case, you're just going to change your fraction depending on which way you're converting. Okay, so we're going to practice that on the next slide a little bit. Okay, so the first problem say convert the following angles from degrees to radians. So we want to figure out 30 degrees is about how many radians. So we're going to take that 30 degrees and we're going to multiply by either pi over 180 or 180 over pi, two equivalent ways of saying a half rotation. If we're converting from degrees to radians, we multiply by pi over 180. And when you multiply fractions, you can think of that 30 over 1 if you want. You just multiply straight across. So on top, I'm going to have 30 pi. On the bottom, I'm going to have 180. And the degrees on the top and the bottom are just going to cancel. If you have no unit of measurement, it is a radian. So if you don't see that little circle to show that it's degree symbol, we have a radian here. The only thing we're going to do now is reduce this. We usually leave radians in terms of pi. So the pi we're not going to touch, just the 30 over 180. What does 30 over 180 reduce to? 1/6. So you can say 1 pi over 6, or usually we'll just say pi over 6 is how we're going to write that. Okay, so 30 degrees is pi over 6 radians. Let's say it's a negative angle, negative 225. Again, I'm going to multiply by pi over 180. Multiply straight across. Negative 225 pi over 180. Okay, again, degree measures cancel there. And then we're just going to reduce 225 over 180. In your graphing calculator, you should just be able to type that fraction in with the alpha y equals button. And when you hit enter, it will reduce it automatically for you. So if you want to try it on your own, you can. You should get negative 5/4 when you reduce 225 over 180. You could also just divide those numbers and then in your calculator hit math, enter, enter, and that'll give you back that fraction. Okay, but it's still negative. That's not going to change. Okay, questions converting that direction? Okay, converting the other direction. We've got radians, we want degrees. So I'm going to start with pi over 3. Now if we're converting from radians to degrees, we flip my fraction. I'm going to multiply by 180 over pi. This time, when I multiply straight across, I'm going to have 180 pi on top, 3 pi on the bottom, and this is going to be a degree. What happens with those pi's? Cancel, and then 180 over 3 is going to give me 60 degrees. Okay, you could also cancel those pi's at the beginning if you wanted to. If you don't want to multiply those through, you're going to have a pi on top and the pi on the bottom, so you could really just think of it as 180 over 3. Make it a little faster for yourself. Okay, negative 3 pi over 4. Let's do a negative one. Negative 3 pi over 4 times 180 degrees over pi, radians. I'm just going to go ahead and cancel my pi's now. One on top, one on the bottom. I'm going to multiply straight across. Negative 3 times 180 gives me negative 540. On the bottom, I get 4. And then if I divide those, negative 135 degrees. It's the same as negative 3 pi over 4. Okay, so now let's figure out what 1 radian is actually equal to. So we know how we form a radian. It's a central angle when we wrap a radius around my circumference of my circle, but this, I think, makes it a little clearer what it actually equals. So I'm going to take 1 radian, and I'm going to multiply by, again, 180 over pi. Now, radians do not always have a pi in them. Sometimes it's just a whole number. If there's not a degree measure next to it, it's a radian, even if there's not a pi there. In this case, when I multiply, I just get 180 over pi. That here is kind of a little ambiguous, like what does that actually mean? If you divide that in your calculator, 180 divided by pi, you're going to get about 57.3 degrees. So what is 1 radian equal to? It's 180 over pi degrees exactly, or about 57.3. So if you look back at that previous picture, that central angle here, that's about that 57.3 degrees that we're talking about. And we can fit about 2 pi, about 6.28 of those around a full circle. Okay? Questions on that? You can use radians to calculate things like we did a second ago, like complements and supplements. You're going to see problems like this on your homework. Find the complement and supplement of pi over 7. I would not recommend, if a problem is in radians, converting it to degrees and then converting back for a couple reasons. Number one, you just added 2 steps to your problem, converting and converting back. Number 2, when you convert, you might have to round, and then when you convert back, you might have to round again. So then you've rounded twice, and your answer is likely going to be wrong. So you're going to just want to start getting used to doing the problems in radians. It's going to make life a whole lot easier, especially when we get to our unit circle stuff, which we're going to use a lot in this class. Okay, so pi over 7, I want to find its complement. Okay, so its complement, it needs to add to how many degrees? 90. Okay, if 180 degrees is pi radians, what do you think 90 degrees is? Half of that, pi over 2 radians. And we're going to see that value on our unit circle coming up pretty soon, okay? All right, so all I need to do is take pi over 2, which is equivalent to 90 degrees, and subtract pi over 7. And that's going to tell me what the complement is. What do you need to be able to add or subtract fractions? Common denominator. What's the common denominator? If I have a 2 and a 7. 14. So I'm going to have, the first one I got to multiply by 7. So that's 7 pi over 14. The second one I have to multiply by 2. So it's 2 pi over 14. And then when I subtract them, denominator stays the same. 14. 7 minus 2. 7 pi's minus 2 pi's is 5 pi's. That's the complement. 5 pi over 14. Okay. Supplement, the only difference now, instead of pi over 2, 90 degrees, minus that radian measure, we do pi, which is 180 degrees, minus that radian measure. What's my common denominator now? First one's over 1, right? Common denominator is 7. So I have 7 pi over 7 minus pi over 7, minus 1 pi over 7. So if I have 7 pi's and I take away 1 pi, how many pi's am I left with? 6 pi's over 7. That is our supplement. And you can check them kind of quick mentally. If I do 1 pi over 7 and 6 pi over 7, if I add those together, I get 7 pi over 7, which is pi, which we know is equal to 180 degrees. That gives me my supplement. Remember, if you get a negative angle, you just say none. Okay. Questions on those? Cool. All right. Let's talk about coterminal angles. Coterminal angles are angles that look the same. For example, 30 degrees and 390 degrees. Okay, so 30 degrees is just that little angle in quadrant 1, right? 390 would be a full rotation plus another 30 degrees. So they start and they end in the same spot, but 390's got an extra rotation in it. That's what coterminal angles are. They share the same sides, but there's rotations between them is the difference. But unless you see that rotation, the angles look the same, okay? In order to find coterminal angles, what this little fancy blurb says is all you have to do, if it's a degree, add or subtract on 360 degrees, a full rotation, Or if it's a radian, we're going to add or subtract on 2 pi. Again, a full rotation. So that's all we're doing is adding or subtracting a full rotation and to get coterminal angles. That's what all that means. Okay? All right. So next problem says find a positive and negative coterminal angle for the following angles. The first problem is in degrees. So I'm going to do everything in degrees. To get a positive angle, I'm going to do 165 plus 360. That's it. 165 plus 360 gives me 525 degrees. That is a positive coterminal angle, meaning if I graphed 165 and if I graph 525, they're going to look exactly the same. One's just got a full rotation beyond the other. If I want a negative coterminal angle, all I have to do is subtract 360. And let's say I had like a giant angle. Let's say I started with like 700 and wanted a negative coterminal angle. I would just keep subtracting 360 until I got a negative number. Here I only have to do it once though. 165 minus 360 gives me negative 195. Okay, so these are very quick. 7 pi over 6. Now it's a radian. If I want a positive coterminal angle, I'm going to take my 7 pi over 6 and I'm going to add on 2 pi. When you're doing it with radians, it's just like fractions. We want those common denominators. So 7 pi over 6 plus, instead of 2 pi over 1, we can think of it as 12/6 instead with my common denominator. And so 19 pi over 6 is my answer. Okay. The negative angle, we're going to take 7 pi over 6 and we're going to subtract 2 pi. I'm going to save myself a second and just say instead of minus 2 pi, I know it's going to be minus 12/6. I know that common denominator, we just did it. So 7 minus 12 gives me negative 5 pi over 6. Okay? Yeah? All right, let's look at the last one. Negative 3 pi over 5, positive and negative coterminal angle, which means I'm going to add and subtract. Maybe we can just condense this and do it all at once. Add and subtract 2 pi. Now I can write 2 pi there, or I could save myself a step and write it with the common denominator. I know my common denominator has to be 5, right? So I'm going to add and subtract on what? 2 pi or 10/5. 10 pi over 5. And then you can get your two answers. If I do negative 3 plus 10, I'm going to get 7 pi over 5. Kind of like my quadratic formula with that little plus and minus, right? And if I do negative 3 minus 10, negative 13 pi over 5. One's positive, one's negative. There's my coterminal angles. Okay, so if you don't want to do it all condensed like that, you can break it apart. You can, add a few extra steps if it helps to show that work, but that's the main idea with coterminal angles. Okay. Any questions on those problems? No, nada? Okay. The next slide is a unit circle. I'm going to give you guys a handout for this only because it's going to be on there on Polaris, the final answers, but I think it's going to be helpful for like your homework in Math Excel to keep this handy, especially as when we get a little further into the unit circle, we add some things to this. This is going to be like a great little study sheet for you to have. We're not even really going to right now get into the definition, official definition of a unit circle, the points on the unit circle. Right now in this section, all we're talking about are angles. So all we're going to add to this are just special angles that we see on this circle in degrees and radians. We're going to put the degree measures on there together, and then you guys are going to work, I guess, as a group to get all the radians to convert them. And we've already got a couple of them done in our work that we've done. Okay, so we've talked about a few things already. First of all, our angles are always in standard position, so they're starting on that positive side of the x-axis. That's 0 degrees. Every quarter turn is how many degrees? 90, 180, 270, and if I do a full rotation, it's back to 360. Do you remember the special angles from geometry that are between 0 and 90? They're ones you had like special formulas for. There were two types of special triangles that had special angles. Do you remember what those are? 30, 60, 90 was one of the triangles. So 30 and 60 are two of our, what was the other one? 45, 45, 90. That's this guy. So those triangles we're going to see in 5-3, and that's what's going to help us get coordinates on this. It's just back to geometry. We're going to use a lot of geometry in this class. Okay, now as we go around our circle, we're just going to count 30 degrees, 15, 15, 30. 30 degrees, 15, 15, 30, because they're all multiples of 30, 45, and 60. So as I'm going around my circle, the next one, if I increase by 30, it's 120, 15, 135, another 15, 150, another 30 takes me to my 180. 210, if I add 30. 225, if I add 15. 240 when I add 15. 270 when I add 30. I got that one. Last quadrant, 300, 315, 330. Good? Okay. All right, let's add some other stuff on here that we already figured out. So we already figured out that 180 degrees is equal to how many radians? 180 degrees, a half rotation is how many radians? 2 pi is 360. So pi is 180, right? That's our conversion, the 180 and pi. That's what we're multiplied by. They're equal to each other. And 0 degrees is 0 radians. We also said what 90 degrees was. What was 90 degrees? It's half a pi, pi over 2. And then I think in a couple of our conversions, I think we got 60 degrees. Did we get 60 degrees or 30 degrees in one of them? If we look back, let me see what we did. 30 degrees and 60 degrees, we have both of those. So 30 degrees, we got pi over 6 when we did that. And 60 degrees, we got pi over 3 when we did that one. Okay, so we're going to divide and conquer this a little bit. I'm going to go around and give you all at least one angle that you need to take the degree measure, convert it to the radian, and then we're going to put the answers up on the board and make sure we get our whole circle filled out, okay? All right, so 45, 120, 135, 150, 210, 225, 240, 300, 315, I'll do 330. Okay. Convert yours and write it up on the board. Okay, so we're going to eventually add some points to this also, and the coordinates, the points, are going to help us find sines and cosines and tangents and all those trig values of all of these different angles. One of the most important things you want to know about this circle is where all these angles are located. If I say 5 pi over 4, eventually, not right this second, but eventually, you should be able to point very quickly to where 5 pi over 4 is located. And then where it's located, we'll be able to draw a triangle and figure out sine, cosine, tangent, any of our trig values. And we want to be able to do it very quickly in our head, because we're going to have a lot of problems that have those within the problem. They're little problems within a bigger problem. So tomorrow, we're going to do, I think, 1 or 2 more slides today. But tomorrow, we're going to finish up this lesson, and then we're going to play a little around the world game with fly swatters, where you're going to come up to the board, 2 people, and I'm going to say an angle. It could be a degree or a radian, and you're going to smack the angle. First one to smack the correct angle stays up. And then if you don't get it right, you sit back down, just around the world style. And then people that can make it all the way around are going to earn a ticket tomorrow for that. So we'll play a fun little game, just kind of like practicing where that goes. Did we talk about tickets in here yesterday? Can't remember. No? Okay, tickets for this semester work a little bit different. So you're going to earn them during specific chapters, but you don't have to use them during that chapter. You do you are limited to how many you're going to use on a test, though. You can only use 3 tickets on a test, but now you can also use them on quizzes this semester. It's just because we have less tests and we don't want to like inflate the test grades too much, okay? So you can use 3 tickets on any test, including the final, and any quiz that's coming up also. You can put up to 3 tickets on it. And when I say 3 tickets, it's not like 3 tickets on day 1 and 3 tickets on day 2. It's 3 tickets total for that test when it comes up, okay? But you should have a good amount of time to earn tickets. I owe you guys some tickets from our escape room, things like our little swatting game we're going to play tomorrow. You guys will have a little more opportunity in addition to your circuit trainings. You do have a circuit training over here that's due at the beginning of next week. If you didn't see it yet, if you want to grab it, it's all about this angle stuff that we're talking about. So I think it's a relatively easy little circuit training if you want to try it and start out with a ticket that way. Okay. Any questions on this? No? Okay. All right. The last thing that we're going to talk about today, which I think maybe you did these in geometry. You guys remember arc length and area of a sector from geometry? Okay. So there are different versions of these formulas. Likely when you did them in geometry, you did the version of the formula that was for degrees. These are the same formulas. It's just been converted into radians. Okay, so that's what you want to remember for these formulas is theta has to be a radian. If it is not a radian, you first need to convert it to a radian to be able to use the formula. So what is arc length? Arc length is what you see marked as S there in blue. It's just part of your circumference. It's a distance around the circle. Area of a sector is like a pie piece that we're talking about. So S equals r theta, where r is our radius. Theta is that central angle in radians. And then area of a sector, similar, 1/2 r squared theta. Okay, so if we look at the bottom here, find the arc length and area of a sector created by an angle of 52 degrees in a circle with radius 7. So I'm going to label some things. I just put like an arbitrary circle here for you to label if you want. 7 is my radius, so from the center, any direction. I usually draw mine that way just because it kind of looks like my standard form angles. Okay, and we have a central angle of 52 degrees. So, I don't know, something like that. Okay, and we are trying to find arc length. So S would be that distance from where the 2 radii intersect the edge of my circle there. And then area of the sector, which would be area of that pie piece. Okay, first thing I have to do, 52 degrees is not a radian. So we're going to take 52 degrees and very quickly, we're going to multiply by pi over 180, which is degrees cancel, 52 pi over 180. And quite honestly, I would just leave it like that. There is no point in reducing this because you're going to just plug it in a formula anyway, so you might as well just leave it. S equals r theta. R is 7. Theta in radians is 52 pi over 180. And you would never tell someone that a distance is like 2 pi. You would probably give them a decimal. So it is appropriate to use a decimal for these answers and round to whatever, Math Excel tells you to round to. So if I do 7 times 52 pi and divide by 180, I get approximately 6.35. And it's a distance around the 7. It didn't tell us what that was. Let's pretend it was like 7 inches. It would be 6.35 inches. Okay? Or if it doesn't label it, you could just say units. Then to get area of the sector, it's 1/2 r squared theta. So 1/2, I would just do 7 squared. That's 49. And then theta, again, is 52 pi over 180. And then again, just type the whole thing in my calculator. This time, because it's area, it's going to be that unit inches, if we put an inch there, squared. All right, so 1/2, 0.5 times 49 times 52 pi divided by 180. I get about 22.2 square inches is the area of that little pie piece that we see. Okay? All right, I think we're going to stop there today. I think we got about 3 more slides, so tomorrow we'll start with those. We'll finish up the last 3 sides, and then we'll play a little around the world practice for the rest of the period. This Math Excel is due tomorrow night. So yes, there's quite a few problems, but they're very quick little problems, like find the complement of this, find the supplement, convert to radians, convert to degrees, that sort of thing. So shouldn't take you super long, but I would definitely maybe get started tonight, try to get at least half of it knocked out, and then you can finish the rest of it tomorrow. Okay? Questions for me? All right, that's it. That's all I got for you.